All right, so our last section for Unit 1 is going to talk about angles of elevation and angles of depression, which means that we're going to have some application problems. So the first one that we're going to talk about is trying to figure out how far away a tree is from the foot of a cliff. And they're asking us to round to the nearest tenth of a meter. Well, if you recall from geometry, here's our cliff, and we're going to be like having somebody up here looking down at the base of the tree. Well, this angle that's created with the horizontal, this is called an angle of depression. So you are actually looking out ahead, straight ahead, horizontally, and then looking down to figure out what that angle is. That would be the angle of depression, not the angle that's made with the cliff. And that is the one thing that people mix up. So they would say, oh, this is your angle of depression, but that's wrong. All right, so to go about solving this problem, we know that the height of the cliff is 800 meters. We know the angle of depression is 37 degrees, 20 minutes. What we're trying to find is this length right here, how far away the tree is from the foot of the cliff. So let's go ahead and draw in this segment. We're going to talk about this being perpendicular. So the ground should be perpendicular with the height of the cliff. And the angle that is formed right here, this angle is considered the angle of elevation. So if you were down below and looking up at somebody at the cliff, that's called the angle of elevation. And the interesting thing is, since the horizontal line here and the ground here should be parallel, the angle of depression and the angle of elevation are going to be congruent. So we know that this angle right here is going to be 37 degrees, 20 minutes. So with that, knowing that the height here is 800, we're looking for x. We can talk about the tangent of 37 degrees, 20 minutes as being 800 over x. So that's the equation that we're going to use. And so we're trying to solve for x right here. So if we do some algebra manipulation, we end up getting x is equal to 800 divided by the tangent of 37 degrees, 20 minutes. And now it's just taking to the calculator, plugging in all the right things, and figuring out what our x actually is. So on our calculator, leaving everything to the end, rounding at the very last second, you would take this decimal, round it to get 1048.9 meters. Okay, so that's one type of question that you're going to be dealing with. Another type of question is going to deal with, ooh, that was kind of blurry, oh well, grade. So if you guys have ever driven to Tahoe, whether in the summer or the winter, you see these signs on the side of the road that tells you the percent grade for how long it is, and they advise caution, certain speed that you should go. And they usually have a little picture of a truck going downhill. And notice this right triangle that's created here. Because what grade is actually talking about is the slope of the highway or the railroad, whatever it is that they are referencing. So what they're actually talking about, since it's slope, is this rise over run gets you the slope of this line, which is the highway that you're driving on. And it's always written as a percent, and usually it's rounded to the nearest whole percent, but we're going to be rounding it more accurately than that. Okay, so we have to deal with grade now. So what are they going to do? Well, first of all, since the grade is just the ratio of the vertical distance to the horizontal distance, rise over run, this should seem kind of familiar to our trig, because rise is the y value and run is the x value. And remember, y over x, that's opposite over adjacent, which should be ringing a bell as how we calculate the tangent of an angle. So grade and tangent kind of go hand in hand. So here's an example. It says the vertical distance is 2.8 meters and the horizontal distance is 59.31 meters. Find the grade. Also, you're going to be finding the angle of inclination, which we'll talk about in a second. So first of all, here is our highway, this slanted hypotenuse. Okay, this is our highway. And they're talking about the vertical distance that you would go, which is going to be this amount. And then the horizontal distance is that amount. Okay, so if we put those values in, they're asking us to find the grade. So they want that percent or slope. right? So we're just going to do rise over run. So your grade is rise over run. Calculate that out as a decimal. So just divide 2.8 by 59.31. We get this big long decimal. But remember, grade is supposed to be a percent, so it's going to look like this, where we have to actually move our decimal place over 2 places to put it as a percent. So that would actually be 4.7% grade. And if this had been on a highway, they would probably have rounded that up to 5%. Okay, so that was the first part, finding the grade. The second part says find the angle of inclination. So the angle of inclination that they're talking about is this angle right here, this little tiny angle that you're looking for. So in a right triangle, if you needed to figure out what that angle is, the equation you're going to use is opposite over adjacent is equal to the tangent of theta. So tangent theta is 2.8 divided by 59.31. So look at this fraction is the same as the fraction we have here, which we already got this decimal, right? So you can imagine that you might have a problem where they tell you the grade and they ask you to find the angle of inclination. So if you could go backwards, where you take this percent, turn it into a decimal, and then that is the number that would get plugged in right here. You just do the inverse tangent of that decimal. So you can see tangent theta is this decimal. It's the same that you got here, which we got from there. And so tangent inverse of that is 2.7029. And so we need to write that as degrees and minutes. So that's going to be 2 degrees and 42 minutes. Okay, so there's all sorts of variations that you can do in these problems. Maybe they give you theta and they ask you to find the grade. Maybe they give you the grade, you have to find theta. Maybe they give you the grade and they want to know something else. I don't know. Maybe they give you one of the vertical length and you have to find the horizontal length, but they gave you the grade. I don't know. Lots of different variations for you guys to play with. Okay, so that's the end of our first unit. Congratulations, you guys made it. Hopefully it wasn't too terribly difficult. And we're out.